Hello everyone. Today I'm going to discuss the fourth problem of AtCoder beginner contest 339, which is synchronized players. So what is the problem statement? We are given a n cross n grid. Now each cell of the grid will contain either a player or a obstacle, or it will be an empty cell. Now there will be exactly two players in two cells of the grid. Now we have to make some synchronized moves to the players. Now we have, at the end, we have to bring these two players in a single cell after the synchronized moves are done. Now we have to print the minimum number of moves is required to bring the two players together. So let's take some example, you will understand it better. So initially state of the grid is like that. Okay, let me copy this and let me write here. Mm, so initially the state of the cell is like this. That means that the first player is in this cell and the second player is in this cell. Now we have to make some moves such that these two players comes to a single cell, but the moves could be synchronized. That means we could choose for any of the direction from left, right, up or down, and we have to move the first player to that direction and also move the second player to that direction. But there is a catch, that if there is a possibility that the first player or the second player can't move in the desired direction, we will not move that player, but we will move the other player. Okay, I hope you get it. Now you have to print the minimum number of moves which will be required to bring the two players together. So let's take this example, how they are solving it. So initially they are moving the first player to the left and second player to the left. Okay, so initially first player will be moved to the left side, second player moved to the right side, left side also. Okay, so the first player will be in this cell and the second player will be in this cell, right? Now what is the second operation? Choose up. So choose up, that means he is trying to go to the upward direction, but this first player can't move to the upward direction because there is an obstacle. Okay, so the first player position will be this position only, but second player can move, so the second player will be in this position. Okay, now the third operation, you might observe that the left will do the trick for us, because the first player can't move, but the second player will move to the position of the first player. So the minimum number of operations needed is 3. So how we can solve this problem? How? So for this, first look at the constants. So the constants on n is 60. Okay, n is 60. So what is the possible time complexities? The time complexity is important for this problem, because the time complex, the constant on n is quite less. So order of n cube or order of n to the power 4 is acceptable. Order of n to the power 4 is acceptable. So order of n to the power 4 is acceptable. That means you can obviously see that if we can take the position of the first player, let's call it p1, and the position of second player p2, and do some kind of traversal, all the possible, we could take all the possible combinations of p1 comma p2, because order of n to the power 4 is possible. So we have to take all the possible values of p1 comma p2 and get the minimum possible answer. So how we can solve this problem? What is the desired algorithm? Now for finding minimum distance, what algorithm we use in a matrix or in a graph, that is called BFS. Okay, BFS or breadth first search. So initially you can see that the player 1 is at p1 position and player 2 at p2 position. Now we can make 4 type of move. The first type of move will be in left, second type of move will be right, third type of move will be upwards, and the fourth type of move will be downwards. So there are 4 type of moves we can do, and after that we will get some state new position of p1 comma new position of p2. So we will do some BFS according to that, and initially the distance is 0, and after each move we will increment the value of this distance to 1. Okay, by 1. So let's jump into the code. The code is also quite straightforward. Initially we are trying to find the position of the players. So in the p vector there will be exactly two values. One will be the position of the first player, and the second will be the position of the second player. Now we'll push the first position, the first the x position of the first player and the y position of the first player, and x position of the second player and y position of the second player, and initially the distance is 0. Now the rest the part is our BFS. Okay, the BFS, there are some conditions in the BFS. Now we will be checking that if the position of the first player and the position of the second player is equal, that means our we have reached at our desired position. Because we are doing BFS, then the top value of the queue will be always having the minimum distance. So that's why when we are at P1 equals to P2, then our distance will be the minimum distance. That's why we are doing answer equals to U4 and doing the break. Yeah, here, right? Now this part is quite useful for problems where we have to move upwards, downwards, right and left. What we can do is that we can take two pointers I and j, and we'll take three values -1 0 and 1, and three values -1 0 and 1. Now there are some combinations of I comma j will be our valid direction. So for that cases, the cases are -1 0 1 0, or 0 -1, or 0 1. So here you can see that absolute value of I and absolute value of j, sum of these two are always 1. So that's why this is useful for that those type of problem. If absolute value of I plus absolute value of j is 1, that means our desired direction is possible. Then initially I am taking the new position of P1 as P1 and new position of P2 is P2. Okay, now if we are checking that if the moving towards that direction is possible for player or not. So that this is for checking that if moving to the left is possible for player 1 or not. So is valid is nothing but to check that where is valid. Is valid is something like, yeah, if it is in the matrix or not. Okay, so here it is checking if the new position is in the matrix or not, and if it is in the matrix, it will check that if the new position is an obstacle or not. If it is an if it is a empty cell, then we will move the pointer in P1 to the new cell. Similarly we will do for the player 2. In P2 will be the position of the player 2 after this move. Now if the we are taking some visited array, this will be 61 to the power 4, and if it is the new position is not already visited, we are pushing it into the queue with the distance, so previous distance plus 1, and we are marking this as visited, right? And at the end we are printing the answer. The problem is quite straightforward, but the implementation might be something tricky, but this is also quite straightforward. This problem is very straightforward. If you have any doubt in any part of the code or any part of the understanding, you can always write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. I will also provide the link of the code in the description box as always. You can check that out. Thank you.